So what does this mean now? This is funny. This is if you understood what we did before, the divided by the reciprocal, you're looking at the same thing just in a different form. Okay, this guy right here is our initial fraction. It's in the numerator of a fraction within a fraction, but we're saying divided by this fraction. So another way of writing it would simply be to say, okay, well, I've got my x cubed plus 4x squared over this thing, which is x squared plus 5x plus 4. Now, that's to say this is divided by, okay, rewrite is a traditional division problem. I'm going to do the rewrite. You don't have to, this, some might call it busy work, but it's to make sure that we see, and it's important that you do see this, that this and this are really the same thing. The divided, this fraction over that fraction is saying divided by this. So, and what we learned in the previous section here is that, yes, we just set this up as a divided by, but what you could do and should do in the future is instead of writing it as divided by the same thing, rewrite it as, times the reciprocal. So that guy's going up top. This guy's going to go down here. I'm going to go ahead and factor as I do it, taking out an x squared, leaving me with an x plus 3. Well, there's another x plus 3, isn't it? You can cancel that even before we're done factoring, but I may be getting ahead of myself, so be careful. X plus 4 and x plus 1, two numbers that multiply together to get 4, add together to get 5. And this guy up here is an x squared waiting to happen. Times, what do you get when you take this out? X squared out of here and here. You get an x plus a 4. And so you cancel your x plus 4s, you cancel your x squareds are gone too. And it looks like, here's the saddest thing. Ooh, all I have is an x plus 1, and so you write x plus 1, you say, great, hey, I'm good at this. Well, you are good at this, but that's not the right answer. If you got an x plus 1 and it's left on the bottom, you've got to communicate in some way, shape, or form that that is on the bottom. On the bottom of what? Everything went away on top. Well, not exactly. You got that coefficient of 1, it's just a mystery number. It's hiding. Okay? When you cancel everything, there's still a 1. If you cancel everything here, it's not 0. And some of you are going to maybe try and put 0. That's why I wanted to make sure you saw the 1. You go, oh yeah, everything's gone. But it's gone because it reduced to be a 1. Same thing. Everything here is gone, but it's because you have the coefficient of 1 left over there. So I know the shaded region, you can kind of see that. It's 1 over x plus 1. So when you do these types of problems, you're basically going to want to rewrite this whole thing. And I would say, if you can factor as you go, great, times the reciprocal. So I'm taking this and I'm moving it up top. So this, okay, divide, yeah, shoot. There's a lot that goes with this. So I'm going to say times. This is divided by this. So I'm now going to say times the x squared plus 4x minus 32 over 2x squared plus 7x minus 4. What I've done there is, instead of saying divide by what you see, I'm saying times the reciprocal. So I've taken these guys here, flipped them, and now I'm going to factor. And it's just the process of doing that. I'm writing it down here where we got a little bit more space. That factors to become x plus 8 and x minus 4. That gives you your negative 32 and your positive 4. I was raised in a time where we did more guess and check than we did boxes and diamonds and stuff like that. And if I know I'm going to combine two things together to get x squared, 2x and x are the items that get me there. And I'm going to have to do some guessing and some checking with a 4. It could be a 2 and a 2. It has to be negative and a positive, or it can be a 4 and a 1 with a negative and a positive combination. But if I'm looking at a 7, that's a big number compared to 2. So one thing I know in the back of my head is that I know I can get close to a 7 with a 2 times a 4. And the only way I'm going to do that is if my outer terms include the 4 over here. So if I do that, I know I've got an 8 right there. And the 1 that's going to go with this guy is going to give me my 1. I've got an 8 and a 1 that somehow have to come together to get a 7. Well, fortunately, that's a negative, because that means I got a plus and a minus. And if it's a positive 7, I need a positive 8. So this plus 4 times the 2 is going to give me my positive 8. That right there is going to give me my minus 1, which gives me the 7. Okay, that was without a diamond, without a box, without whatever it is, whatever. Okay. Now you can still do your diamond in your box. Now this guy here, the source of that gives you, you do the 3 and you get the 24x squared and you get your 25x and you get your 24x and your 1x and you go through the whole process. 3x squared plus 24x plus 1x plus 8. I took this thing here and replaced it with those two guys from here. You take out your 3x, x plus 8. You take out your 1, x plus 8. So your factors are x plus 8 and 3x plus 1. Okay? Now, you got a lot of things that you can sort of cancel here. I would say you got to go through the same process again. It's a bit tedious. This is the hardest one on the page. It's not hard, it's the most involved. I'll give you this. You got a plus 1 and a minus 1. Those are the only things that are going to get you that minus 1. And your outer and your inner terms are going to somehow come together to give you a 1x. Well, the two numbers that are 1 apart from each other to give you this is a 3 and a 2. And if you're going to end up with a negative 1, then your 3x is going to be here because that's going to give you your minus 3x. Your 2x is going to be here. That's going to give you your positive 2. Negative 3 plus 2 gives you that negative 1. If you understood that, great. If you got to go back and do your diamond in your box, then that's fine as well. It's a cancel fest at this point. Cancel all those, you end up with an x minus 4 and an x plus 4. And these are done roughly the same way, but a lot simpler in terms of the process.